Well, let's continue to explore this data and let's find the mode. And the mode is the most. And so in this data set, we would make a frequency of each piece of data. So we take each value of data and we'd write it down. And we'd have one of each value, except for 235. We would have two values in 235. And so 235 would be the mode. It is the most frequent. Now, mode can take some different ways of being described coming through statistics, but we're looking right there for the most. And so this weight data, if we look at it, had a mean value. Pull back where my mean was. I guess I could scroll up. It's still on my blackboard, but it's also in my book here. So of 258.6. Definitely getting trailing pen today. And it had a median of 268. And a mode of 235. And so these values describe our shape, it describes how the data is distributed, what the data is doing, and where the data is lying. And so we're putting numerical numbers to things that we are using. And occasionally, you'll get pieces of data that are bimodal, where there's more than one thing that has high frequency. All three measures have a meaning, and the meaning can really tell you about the data set you're looking for. And so if we want to compare ideas, we can kind of look at where the mean is and the median. And so what we tend to say or can see is when the median and the mean are together, our data is balanced. There's equal amounts on either side. All right? And this will be a shaping that we have. But when the median and the mode start, or median and the, let me redraw this here. Trying to hear me typing away there. Let me just get a graph up here for you. Use some straight lines. Interesting. There we go. Close to straight. All right. So if I have some distribution, and for right now I'm going to use a curve. All right, this is like a histogram. There's lots of things in it. And if our curve is fairly symmetrical, then the mean, the median, and the mode are all in the same place. And so we call this a symmetrical distribution. The mean, median, and the mode are, in a perfect distribution, they would be the exact same value. In general, they're really close. They're off only by a small amount compared to the size of your data range and your data values. Another type of distribution we can have here, draw another graph, is uniform. And a uniform distribution actually pops up in probabilities every now and again, and it's a building block of other distributions. But a uniform distribution has data bins that have the same height all the way through, and they fill the space. And notice I'm using descriptors here. We're filling the space. Right? These are equal bins on a histogram. These two will have your mean and median in the same place. But the mode doesn't exist because each bin is getting the same value. And so this has no mode. And this is called a uniform distribution. So the mean, median, and mode come together, and they start telling us about the data, and they become things that we can actually use to compare visually and numerically. So notice I'm talking in terms of equalities, not just positional equality, right? So if mathematically the mean and the mode are equal, we get these shapes, or the mean and the median or mode are all equal, we get these shapes, and those shapes say how our data lines out. Well, another type of distribution we can have, if I can get my axes to draw here, is when they're skewed. And if our data comes across, and again, I'm going to use general probability distributions to draw these things, not histograms for right now. If I have a long tail on the left, this is called a left skewed distribution. I feel like I'm writing like a 2-year-old today. Again, it's the problem of the pen. I got my pen replaced. It's working fine. I have to use the old one today, and the old one's all over the place. Now, what ends up happening on a left skewed distribution is the mean is here, and the mode is here. And the median is usually here. Right now, I'm just going to put the median and the mean on, because they're the things we want to compare. Modes will be the most frequent point, and they tend to stack up here. The mode in this case, it will usually be around or in between these two. But what's nice here is if the mean is less than the median. Notice how that points left, right? The inequality sign is pointing left. The mean is less than the median, it's left skewed. Well, and the opposite thing happens for a right skewed. It is the mirror image of this. Again, let me draw a general distribution function with a tail to the right. And so what's going to happen here is our mean value and here's our median value. And so if our mean, or x bar, is greater than our median, it's right skewed. And tails become important. The idea of tails and which direction a tail is in has some ideas. And to be honest, our uniform distribution had 2 tails. When I draw them correctly, they're equal. And so these values that we're looking at actually describe shape. We're now attaching number to them so that they come back and tell us our shape. And our shape tells us where our data is.